This video deals with Java inheritance. So we're going to start by looking at a class diagram. And this class diagram is done in the Unified Modeling Language, more commonly known as UML. So in UML, we have these boxes that contain 3 sub-boxes, and this represents a class. If you remember our example from the objects and classes, we used an employee object. So again, we're going to extend that sample. So we have our employee class, and like we previously had, it has a first name field, a last name field, and an ID field. We also have an hourly wage, and we've got a couple methods: get salary that returns a double, and print that just gives the information of the employee. So that's our base class. Now we're talking about inheritance. And inheritance means that we are going to take pieces of a class, or I should say use a class that has several pieces that can be reused by other specializations of this class. Okay, what does that mean? Well, we have an employee, and we have several employees, and then suddenly we start hiring people part-time. Well, we can extend that employee object, that class, with a part-time employee class. And what's the difference between our employee and a part-time employee? Well, an employee, we're going to just assume they work 40 hours a week, because that's a typical work week. But with a part-time employee, the hours may vary. And so that is actually what we're going to capture in our part-time employee that is not in our employee. So we see here our part-time employee class with another field called hours per week. And it also has this get salary method. This arrow we see here is talking about the inheritance relationship that this part-time employee is extending the employee class. And that kind of makes sense. It's extending the functionality beyond what the basic employee class already had through adding this hours per week and changing the calculation of get salary. So now this is something that's very important. By extending this employee class, part-time employee pretty much gets to use everything here. But now the calculation for get salary is going to be different for our part-time employee. It's going to vary based off the hours per week. So we're going to have a different implementation that will override the implementation in the parent class. So let's look at this in code. If we go to our Dr. Java code, we have our employee that is pretty much the same as last time. I changed the some of the fields around a little bit. And we have all of our private fields. We have now a protected field so that our subclasses can use it, called hourly wage. We have our constructor we previously had. And all the same methods: get ID, get salary, and our print. Now we've added another class, a second class called part-time employee, and you see that extends employee. That extends right there is creating this relationship that this class, this part-time employee, can use anything that is public or protected in the employee class. So here we have an hours per week, which we do not see in the employee class. It's only in the part-time. And a constructor specific to the part-time employee. Now this part-time employee constructor is a little different from what we've seen before because it will call the class that it extends constructor as well. When you go ahead and create this object, you're going to call the object's constructor. It's going to go ahead and call a super constructor, the parent constructor of the class that it extends. So it will call the employee constructor. Now, since it takes parameters, the constructor we have for employee, we need to pass that to it somehow. And the way we do that is through this keyword super call. So super is saying call the constructor of the parent class, the base class, and pass the parameters to it as if you were constructing the object by itself. And now the next interesting item is this get salary method, because we have a get salary method already in the employee class. This get salary method, which we now find in our part-time employee or our subclass, is going to go ahead and override the parent class's implementation. Well, so what does that mean? Let's look. If we go ahead and use these classes in our main, we create an object of type employee, and we create an object of type part-time employee. And then we go ahead and call the print functions. We are going to see our first employee printout, polyparrot, yearly salary, and our second employee printout with their yearly salary as well. The print function that they're both using is the same, but the salary calculation is done differently. The salary calculation for employee is going to call the one within the employee class, where the one for part-time employee is going to override what is in that employee base class and call this implementation of get salary captured in the part-time employee. So that's a lot to take in. I have another example here, which I will post this code to the learning module so you can look at it more closely. We have, I'm being very literal about inheritance in this example. We have class subclass extends base. So we have our base class, we have our subclass that is extending from our base class. We have an integer called subclass int, which is defined in the subclass. We have our constructor, which is calling our super base class constructor. We have an override method. So this method is going to override the one that we see in the base class, and then we have a method that is only in the subclass. Here's our base again. We have our string, which is defined within the base class. We have our base constructor. We have our method that will be overridden, and we have a base class method that's only in the base class. So we'll go ahead and create an instance of base and an instance of subclass. And so now, what do you think will happen with these lines below? Okay, let's look at the first set. So here, we're going to call our override method first with the base class and then with the subclass. What do you think would happen? Well, we should see that this will print that I am from the base class, and then this one should print I am from the subclass. Now we have a call to the base class method, which is defined within the base class, called from the base class, and then called from the subclass. What do you think will happen here? Well, the behavior should be the same because we're not overriding the method in the subclass, and so they're both calling the method defined in the base class. Okay, and now we have base.subclass only method, subclass calling the subclass only method. What's going to happen here? Let's try compiling and running for a change. Oh, okay, we compiled. What happened? We get an error. It says cannot find symbol. Method subclass only method, variable base of base type. Okay, can't find the method. Why can't it find the method? Well, because this is defined in the subclass. The base class can't see things that are defined only in the subclass. So this is a compile error and is not valid code. Okay, so then we have the subclass calling subclass only method. Now you would expect this to work because here we have an object of the subclass and it's calling a method that's defined within it. But let's see what happens when we compile. The same error that we previously saw with the base class object. Why is this happening? Well, that's because when we define these objects at the top of our main method, we actually made it a base class object. The type is the base class, but we instantiate it to the subclass. You can do this because subclass inherits from the base class, so it's considered a type. It is considered a type of a base class. The problem is when the compiler is now looking at this, it sees base class, it tries to find subclass only method in the base class, and it doesn't. At this point, what can we do? Well, we can cast. We can actually cast our subclass object to the subclass type, making it that type, or creating a copy of it, or I should say a reference of it, that is actually the type of the subclass. So this becomes invalid code. We do the cast to a new reference, and then we're going to call. Now here's where it gets even more confusing. We're going to go ahead and print our subclass and print our subclass cast. And what you'd expect to see is that the first one will print out saying, I'm a base class type, because that's how it was treating it. And the second one would print out, I'm a subclass type, because that's what it is defined as, and that's how it's being treated. What actually happens is there's a toString function that is defined in the mother of all object with a big O. And in the toString object, it calls getClass. GetClass is actually a function that is overridden for every class by the compiler. And so you will actually see the actual type of the class being printed out, the subclass for both of these print statements. Now here I'm trying to show if we access the base string method, what will happen. And in this case, these should both work as expected. We should see the base string printed for both the base class and the subclass. And now here, we're trying to print the field that's defined in the subclass. Again, like we saw with the methods, the base class will not have access to it because it's defined in the subclass and not in the base. The subclass object that thinks it's a base object, again, will not have access to it because it won't be able to see it. Finally, the subclass casted object will be able to access it because it knows its type is subclass. So I hope this was a good overview of inheritance. I am going to post these two files so you can look at them and take a look at the code and get a good understanding for it.